You ever look at a huge, interactive 3D world and just wonder, how? How is all of that built? Well, today we're actually going to build one right from the ground up. And we're going to start with the smallest possible thing, a single pixel. We're going to follow its journey from just a tiny dot of light all the way to a universe you can actually explore.
So yeah, how do you do that? How do you go from one single point of light on a screen to a whole complex 3D space you can move around in? It sounds impossible, right? But the secret is, it all comes down to a few really clever and actually surprisingly simple building blocks.
All right, so let's start our journey at the absolute lowest level you can imagine, the digital canvas itself. I mean, before we can even think about drawing entire worlds, we need something to draw on, right?
Okay, so what we're building is what's called a software renderer. And the key phrase to focus on here is without relying on dedicated graphics hardware. What that means is we're not using a fancy, powerful graphics card, a GPU. Nope. Instead, every single calculation, every single decision about what color a pixel should be is being handled directly by the computer's main brain, the CPU. And doing it this way, well, it gives us total control, right from the ground up.
So what even is a screen in our little software world? Honestly, it's just a giant grid of pixels. And if you look at this line of code, you can see what a pixel actually is. Think of it like the fundamental atom of our universe. It's just a super simple little container that holds 3 numbers, one for red, one for green, and one for blue. That's it. Our entire universe is literally just a huge list of these tiny color buckets.
And how do we control all this? Well, it's all handled by this one single, incredibly powerful function called _setpx. You can think of this as our universe's one and only tool. All it does is take an X and a Y coordinate on our grid and a color, and then it just plops that color right there. Seriously, every complex shape, every character, every explosion you'll eventually see, it all just boils down to calling this one simple function over and over and over again.
Okay, so we can color one pixel. That's a start. But let's be real, it's not exactly a universe yet, is it? So the next logical question has to be, how do we get from a single dot to actual recognizable shapes?
Well, the way we do it is actually pretty logical when you break it down. First, we have our base function, _setpx, which draws a single point. Then we build on top of that. We write a new function, drawLine alpha, that basically just calls _setpx over and over again to connect 2 points. And then, once we can draw lines, we just define 3 points and use our line drawing logic to fill in the space between them, and boom, we get a solid triangle using P3D draw text triangle. It's that simple, point to line to shape.
And that brings us to like a fundamental truth of all 3D graphics. The triangle is everything. Why? Well, it's the simplest possible 2D shape you can make. You see, any 3 points in space will always define a perfectly flat plane. So every complex 3D model you've ever seen in a game or a movie is secretly just a collection of thousands or even millions of these simple little flat triangles all stitched together.
So, okay, now we can draw flat triangles on our flat 2D screen. That's great, but our goal is a 3D world, right? This next part, this is where the real magic trick comes in. How do we create the illusion of depth, of a third dimension, on a screen that doesn't actually have one?
I mean, this is the core challenge of all 3D graphics, really. Our screen is flat, but the world we're imagining has depth. The solution is a concept called projection, and it's basically just a bit of clever math that's designed to mimic how our own eyes perceive the world.
Step 1 is pretty straightforward. We just need to know how far away something is from us. So, in our 3D world, we have a virtual camera and a virtual object. Each one has a z-coordinate, which is just a number that represents its depth. All we do is subtract one from the other, and that difference gives us the object's distance from our viewpoint. That's our depth.
Now, this formula, this is the key to the whole magic trick. It's what we call perspective projection, and it captures a really simple, elegant idea. Things that are farther away should look smaller. See, by dividing an object's size by its depth, we make sure that as that depth number gets bigger, the object's final size on our screen gets smaller. It's a perfect imitation of how our own eyes work. And here you can see the final result of that whole process. We start with a single point in our 3D world, we call it a vertex, and it has an X, a Y, and a Z coordinate. But after we run it through all that projection math, we're left with just an SX and an SY. Those are the final X and Y pixel coordinates on our flat 2D screen. We've done it! We've translated a point from a 3D space into a 2D dot that we can actually draw. Fantastic. So we can now take a 3D triangle, project its 3 corners onto our 2D screen, and draw the whole thing. But a world isn't just one triangle, is it?
It's a whole scene, packed with objects. So how on earth do we manage all of that at once?
The answer is something we call the engine's heartbeat, or more commonly, the game loop. It's basically an infinite loop that just does the same list of things over and over, super fast, like 60 times a second. It checks if you've pressed any keys, it updates the positions of the camera and all the objects, it projects all that 3D stuff onto our 2D screen, and then it draws the final picture. And then, it does it all over again. This constant cycle is what makes the world feel alive and interactive.
But wait, there's a huge potential problem here. What if we just draw our triangles in a totally random order? You could have an object that's far away get drawn on top of an object that's close up, and that would completely break the illusion of depth. The solution is something called the painter's algorithm, and it works exactly like it sounds. Just like a real painter would paint the sky in the background before painting the trees in the foreground, we need to draw the things that are farthest away from us first. So in every single frame, before we draw anything, we use a simple sorting function to arrange all of our triangles, from back to front. Okay, let's take a breath. We've built the canvas, we can draw shapes, we can create the illusion of depth, and we can manage an entire scene. Now for the fun part. Let's see how all these pieces come together to create a truly interactive application, a real digital playground. So, here's our demo app. The user sees a pretty simple interface. Let's say they move their mouse over and click the button that says Add Shape. What's actually happening behind the scenes when they do that? Well, that click gets detected inside that game loop we just talked about, and it triggers this specific function right here, P3D_UI button. This little piece of code is responsible for everything, drawing the button on the screen, checking if the mouse is hovering over it, and most importantly, telling the rest of the program, hey, I've been clicked. This is the bridge that connects what the user sees to the engine's logic.
And because our engine is always listening for that mouse input, we can build some really powerful tools. For example, here, a function called P3D_BodyDeform is running. Every single time the user clicks and drags their mouse on the model, the engine finds the closest vertex, one of those 3D points, and just moves it. You're literally sculpting the shape in real time.
And this is the real payoff, isn't it? We haven't just built a system that shows a static picture. We've created a dynamic, flexible world. It's like having a lump of digital clay. We can add to it, we can sculpt it, we can interact with it, and it's all possible because of those simple building blocks we put in place, starting all the way back with that one single pixel. You know, it's kind of amazing to think about. This entire thing, a fully interactive 3D environment, it all started with the simplest possible action, just coloring one dot. By layering simple logic on top of more simple logic, we built a whole universe. It's such a powerful reminder that pretty much every complex system out there is just a collection of simple ideas executed really well. So the only question left is, what will you start building?